This video we will study Henry's law. It says that mass or solubility of a gas dissolved in a given volume of liquid is directly proportional to the pressure exerted on the surface of liquid in equilibrium with the liquid. In equilibrium with the liquid, provided gas should neither undergo dissociation nor association. That is, should not undergo any chemical change. The focus should be gas should not undergo any chemical change, and another focus for that in the definition will be mass or solubility of the gas dissolved in a given volume of liquid should be directly proportional to the pressure exerted on the surface of liquid. So we are taking an example. First of all, we are taking the formula M directly proportional to P according to definition. S will be directly proportional to P. So M is equal to K into P. S is equal to K into P. M is the mass or S is the solubility whose of gas dissolved P is the pressure that is exerted on the surface of liquid, and K is equal to constant. So here we are saying that pressure is exerted on the surface of liquid, but generally what we have seen when we go to the market and purchase any soft drink, and we see that soft drink bottle has some space between the liquid and the lid. There is some vacant space, है ना? There is some vacant space, and then this is the lid, and the gas is dissolved there, and this liquid is of V volume, that is a fixed volume. Definition is saying that mass of gas or solubility of gas is directly proportional to the pressure exerted on the surface of liquid. But we are exerting the pressure on the lid of container. Actually, this pressure is exerting on the surface of liquid. So this vacant space had a gas in it, which because of high pressure get dissolved into liquid. Some of gas there that in space is also there. Any disturbance causes the formation of bubble that come to the vacant space, and same volume of gas get dissolved. Yeah, same mass of gas get dissolved into the liquid, so that the volume of container should not increase and it should not get burst. This is the reason the vacant space is left into the container. The second definition of Henry law is partial pressure of a gas dissolved in a given volume of liquid is directly proportional to its mole fraction. To its mole fraction. What is it? That partial pressure of a gas. So we have taken a container. Here we have dissolved a gas. Mixture of gases is dissolved. This is the volume of fixed volume V liquid, and this is a gas dissolved into it. We are applying the pressure. So there are a number of gases in the vacant space, right? So their pressure will be the partial pressure. So P directly proportional to X. P is equal to KH into X. What do we mean by KH? P is partial pressure of gas. X is mole fraction of gas dissolved. Mole fraction of gas dissolved. And your X is the, KH is the Henry law constant. KH is the Henry law constant. Now coming to the next point, that where is it applicable and what is the meaning of Henry law constant. So we have taken the formula P is equal to KH into X. So P will be equal to KH upon X. P will be equal to KH upon X. What does it mean? It means that X is what? X is the mole fraction of gas dissolved. We can say it in terms of solubility as well. So we say that higher the temperature, if the temperature is increased for any liquid, like we boil water, we heat water, then bubbles come out of the liquid. It means solubility of gas becomes very low when the temperature is increased. So higher the temperature, lower will be the solubility of gas. Then this is the mole fraction which we are considering as a solubility. The denominator value is decreasing as we are increasing its temperature. It means higher the value of KH. So we can say that KH depends on temperature. The value of KH depends on temperature. That is, KH is directly proportional to temperature. Higher the temperature, lower the solubility, then higher will be the value of KH. Now we are coming to limitations of Henry law. Of Henry's law. Number one, temperature should neither too high nor too low. Number 2, pressure should neither too high nor too low. Third, gas should not react with the liquid chemically, otherwise Henry's law will fail. The gas should remain in the liquid. Gas should remain in the liquid. If temperature becomes too low, it will become highly soluble. If the temperature becomes too high, then gas will get escaped out. If the pressure is very low, the gas will not dissolve. If the pressure is very high, then gas will get dissolved. So it should be dissolved moderately. So number 4, gas should neither undergo dissociation nor association. Gas should neither undergo dissociation nor association. Gas should not react chemically with the liquid. If it will react chemically with the liquid, then it will cause poisoning effect. Next definition will be the application of Henry's law. Where is it applicable? Number 1, in soft drinks. Soft drinks are prepared and based on Henry's law, because their pressure and that carbon dioxide gas is dissolved into the liquid. Number 2, that mountaineers carry oxygen cylinder. Reason, because at high altitude oxygen is very less dense. It means less oxygen is supplied to brain during breathing. To brain during breathing. At that time, they feel nausea, start vomiting, and unable to think. This condition is called nausea. Second application of Henry's law is scuba diver. Scuba divers carry oxygen cylinder. When they go deep, more air get dissolved into the blood. and when they come at the surface, the air comes out of the body, air comes out of the body in the form of blisters, that there comes out of the body, and blisters are formed on the muscles, which is very painful, which is very what, painful. So, and this condition is called bend. In medical, this condition is called bend. So first of all, to avoid, to get rid of this condition, they are given medical immediately. And very important note to remember, that they carry oxygen cylinder during diving, which is a mixture of, which is a mixture of what, 11.7% helium, 56.2% nitrogen, and 31.2% your oxygen. It is 32.1%. 32.1% oxygen. The reason of taking this helium, because helium dilutes the poisoning effect of nitrogen. Because when nitrogen, if nitrogen of air like 78.1% or 78% nitrogen which is present in air by volume, if this air is given to the into the cylinder, then that nitrogen will cause poisoning effect. So nitrogen when dissolved in the blood causes poisoning effect. it it is possible only when the pressure is very high. So